Okay, students, see the question number 28. Question number 28 is about the two-port network. Okay, so for the network shown in figure, which of the following statement is true? So network is given like this, two-port network. This is what resistance. Here is this is my resistance R1. This is resistance R2. R2. Okay, so this is my capacitance here. Here it is capacitance, and this is capacitance C1. This is capacitance C1 R1 R2, and this is my dependent source that is connected across this capacitance, dependent current source. Yes, this is beta I1, and here this is current I2, and this is my V2 positive negative, and this is my V1 positive negative, and this is ground. Now see, asking which of the following statement is correct. So now we have to find Z parameter. Okay, so let us find Z parameter first. First apply KVL here. Okay, so now whatever current is here, reverse current is here. That is how much? Beta I1. Okay, beta I1. Now here entering current is equal to leaving current. If you see, this is my I2 and this current is I1. How much? I1. So then this current is nothing but I1 plus I2. Yes, I1 plus I2. So now see here, just by applying KVL, in loop 1, we will get V1 minus R1 I1 minus, that is R2 into I1 plus I2. I1 plus I2 is equal to what? 0. Yes. So now see here, V1 minus R1 I1 minus R2 I1 minus R2 I2 is equal to what? 0. So this is what? V1. V1 is equal to what? V1 minus R1 plus R2 into I1 minus R2 I2, yes, is equal to what? 0. So this is what? V1 is equal to R1 plus R2 I1 plus R2 I2. Okay, this is my equation number 1. Equation number 1. So let us see. Now by applying KVL in loop 2, just apply the KVL in loop 2, we will get what? See here, V2 minus V2, what? This is what? V2. Okay, so V2 minus V2 minus beta C1 I1 minus this is what? R2 I1 plus I2 is equal to what? 0. So this is V2 minus beta C1 I1 minus R2, okay, R2 I1 minus R2 I2 is equal to what? 0. So this is what? V2 minus, just take it, beta C1 plus R2 into I1 minus R2 I2 is equal to what? 0. Now see here, V2 is equal to beta C1 plus R2 into I1 plus R2 I2. Okay, this is my equation number 2. So this is my equation number 2. Now see here, just arrange this in the form of Z parameter. This is what? V1 V1 is equal to how much? R1 plus R2 I1 plus R2 I2. V2 is equal to beta C1 plus R2 I1 I1 plus R2 I2. Okay, so now see here, V2, these are two equations. Arrange this. V1 V2 is equal to R1 plus R2. This is what R2. This is beta C1 plus R2. Yes, and this is what R2. Okay, so this is my Z matrix. Yes, Z matrix. Now if we will compare this, and this is what I1 I2. Yes, just compare this with Z parameter. So V1 V2, this is my Z parameter matrix. Yes, which is nothing but, if you see, Z11 Z12 Z21 Z22 Z22. Yes, Z11 is not equal to Z22. Z11, if you see, Z11 is not equal to Z22. Z22 means it is not, this means what, not symmetrical, not symmetrical. Okay, so then here Z21 is not equal to, Z21 is not equal to Z12, then this implies not reciprocal, reciprocal or non-reciprocal. Yes, so therefore by option we can say that it is neither symmetric nor reciprocal, neither symmetric nor reciprocal. Therefore option number D is correct. Okay, option number D is correct. Nothing is there, just simply apply the KVL in loop 1 and in loop 2. For reciprocal, you can say from here only, if any two-port network, if any two-port network contain independent source, directly, indirectly or blindly, you can say that this network is non-reciprocal. Okay, this network is non-reciprocal. In any two-port network, if there is any dependent source, either it is voltage dependent source, current dependent source, in that case we can blindly say that the network is non-reciprocal. Yes, two-port network is non-reciprocal. Okay, there no need to check for reciprocity, reciprocal. Okay, reciprocal condition you can say directly. Okay, so these are all about this question. Okay, so nothing is there, just simply apply KVL and KCL. KVL, simply apply KVL, and then after that you arrange this in Z parameter formations and just compare whether this diagonal element is equal or not. Okay, according to that we can identify, is it reciprocal, is it symmetric. Okay, so that's all for this question. Okay, so thank you very much. Okay.